I know I talk up pandas a lot, with good reason, but one of the best parts is how easy and intuitive it is to filter data frames and series based on values and conditions in rows and columns. Oftentimes, you'll find yourself selecting a row based on a condition. Let's start with an example for a series and use a column that is categorical, meaning it references a string. Say we want to filter the data frame to only show players who play for the Oklahoma City Thunder. We will filter for OKC in the team, which is TM column of the data frame. We will use the Python double equal sign for a comparison. So if we read in our data, and let's just get a quick sample of our data to know what we're dealing with. And you'll see the TM team column in our data frame. So what we are going to say is we want to filter the team column to be where it is OKC. So let's run this and see what happens. What's interesting is we see this true or false for each row. What is happening underneath the hood is this. First, Pandas is evaluating every row to see if the team value is OKC. It returns Boolean value stating whether it is true or false based on the condition that we set. In order to get specific rows where the Boolean is true, we need to pass this code into new square brackets. So we'll take this, and what we're going to do is wrap another bracket, and this will let us get every row where the value is true and pass over the rows where the value is false. So if we put this in a bracket, now what's going to happen is we get just a data frame where the condition team equals OKC is true. To get a new data frame, we need to save it as a new data frame object. So we could come in and create an OKC data frame. And now all of a sudden, we have our data frame and a new data frame object that we can use for manipulation. There is a way to make this easier on the eyes. As you can imagine, running multiple conditions has a lot of square brackets, and this can be cluttered. What we can do is assign the inner code to a variable and then pass that variable into the outside data frame. So let's say we had the df team is equal to OKC, and let's set this equal to an OKC variable, and then we're going to run df, and we just want that OKC variable. And you'll see we get the same output, however, it looks a little bit nicer, and then it allows us to kind of go in and change the input in an easier way. Again, it will create a new Boolean series, and we need to do something with it if we want to use it, so we could always save this to a variable of OKCDF if we wanted to. The same conditional formatting that you come across in all coding and math also applies to pandas. For example, we can use the OR operator to check if either of the two statements are true. So let's say we want to find every player that plays for either OKC or LA. We would then write df team equals OKC, and let's wrap this in parentheses, and then we'll use the OR operator, and we'll say df team equals LA Lakers, and let's wrap this one. And again, if we ran this, we would just get the true false. And what we want instead is a new data frame. So let's wrap this. And we're going to save it into a data frame called dual df. And now if we run it, we should see all the players for OKC or for the Los Angeles Lakers. And again, it might be easier on the eyes if we wanted to put these in their own variables, at which point we could run DF, OKC, or LA Lakers, and we get the same output. The AND condition can also be used. So rather than checking if the player is for OKC or LA Lakers, you can check to see if both statements are true. And if they are, then extract the row. So now let's grab every player that plays for Oklahoma City and has started more than 10 games. What we can do is say df team equals OKC. And let's wrap this. And then the ampersand for and df. And sorry, this is games started is greater than 10. And again, we need to wrap this in the square bracket so we don't just get the true false boolean. And here you have it, everyone that started more than 10 games for the Oklahoma City Thunder. And one last time, let's look at it. Just saved it to two variables instead. So OKC. And we'll do game started. And then we can run and df equals df OKC and GS. And now we have to print that. And we get the same output. We can even get rows where players are part of multiple conditions. So for example, let's say we wanted to find everyone who was in the 50, 40, 90 club for the season. Now I don't know necessarily if anyone is going to qualify, as it's a pretty rare club. So let's say uh, 50 for field goal. And we'll say 50. 50 for field goal. We'll do 44. And you see you can't start with a number. And this is going to be 3p percentage greater than 0.40. And free throw greater than 90. And that is FT percentage, and that is greater than 90. And then what we want to do is find where field goal 50 and 3.40 and free throw 90. And let's save this to a shooter's DF. Now let's see if anybody actually was in the 50, 40, 90 club this year. And it looks like David Stockton and Antonius Cleveland did it in a mere 9 and 42 minutes played. Congratulations to those both. Now if we grabbed our OKC, we grabbed our Lakers, and we grabbed our game started again, And I'm going to run them again just so everyone can see it, although we wouldn't have to. If we use an and an or operator, then we need to wrap the and within parentheses so Pandas knows what to execute first. So if we want to get people that played for either OKC or LA Lakers and started more than 10 games, we would write df and in parentheses OKC, LA Lakers. So it will look for either or and then go through and check if they've started more than 10 games. And here you'll see it is lowercased. And so here are everyone on the Lakers and the Oklahoma City who started more than 10 games. And I am using last year's data from the 2017-18 season. Another way you can use Pandas for filtering is with the is_in method. For this method, we chain it to a data frame series and pass a Python list as a parameter. The Python list contains a list of items we want to check against. Pandas will loop through the column and check if the value is in the list, returning a Boolean series like we are used to. The Python list makes it easy to modify and expand the list if anything changes. So for instance, if we wanted to check df team is in, and we had a list of different teams, OKC, LA Lakers, and Chicago. We could run this. And again, you'll see there's the Boolean, so we got to wrap it one more time. And now this is everyone who played for the Bulls, the Thunder, or the Lakers. 62 different players. And again, if we said this is a Python list, oftentimes it's easier to modify. And we run that list, and we can merely replace it and we'll get the same information. We'll use this for our projection model when filtering based on games played, since we want to drop players who played less than about 10 games so they don't skew our results.